Hi. So I done some more work with my random number generator experiment. A couple things happened. One was I was updating the program to be like just have the code cleaner, and I had it implemented in Circuit Python, and uh, I was trying to use some new library, and I don't know. I just locked up the thing, so it became a little bricked Itsy Bitsy M4. Not bricked forever, but I could not get Circuit Python like just reinstall it. That didn't help. Apparently, whatever code I had there running was running badly, and I didn't know how to. When you upgrade Circuit Python, it doesn't delete your Python programs. That drive stays intact, and I just didn't know how to delete that drive. So I was like, this is a real hassle. I know Python is fun and it's a simple program, but once I started doing things a little more complicated, I had this trouble. So I said, just I'm going to wipe it, and I still had a backup copy of the Python code, but I wiped it and said I'm going to use C++ to program this thing. So that would be our using the Arduino framework to program it, and I'm using VS Code instead of Arduino IDE. Here's a plug for VS Code. VS Code plus the Platform IO extension. It's so much nicer. Arduino, maybe they'll get their act together, but their current 2.0 IDE, it's not good enough for me. I think it's good enough for a lot of people, but not for me. So Visual Studio Code, it's a beautiful environment, and Platform IO knows how to use the Arduino frameworks, the Arduino SDK. It could use all their alternate SDKs, and so it's nice. Anyways, that's a little bit of a background about what was going on. So then I rewrote the program, and it's such a tiny program when it's in C code and compiled, a few thousand bytes, and it was working. And I added a little like a you could type at the terminal, and oh, I forgot to say I wanted to do the experiment, and in the experiment, I'm going to need to log the current bias to a file. So I added a little micro SD card module to the setup. So wired that in, and then because I need to deal with a micro SD card, there's a thing that happens. So suppose this is easy enough, just write the samples to the card. Okay. So just write it constantly. Okay. Great. And then you could, take that card out, plug it in your computer, and load that into a spreadsheet, because I was writing out a CSV file, comma separated values, if you don't know what CSV is. And it would be beautiful. But here's this one thing about SD cards. Suppose it's writing, and you pull the plug or you pop the card out, you're going to trash that card. So I have no other buttons on the Itsy Bitsy to use to as inputs. So I wrote a little like a serial little monitor program. So basically, while it's doing things, if you hit spacebar, you go into a little command mode, and in command mode, you can properly shut down the SD card before you unplug things. You can format the SD card, and you can list the contents, and you can get the contents streamed out the serial port. So a little more convenient than having to pop the card out and stick it in your computer and just list it out, and then using the screen program, if you know Linux or even Mac OS, but Linux variants, Unix variants have a terminal program called Screen. Well, Screen lets you save a log of everything that went to the terminal to a file. So what I am able to do is get into monitor mode and say list the log file, the CSV, and it will go out through the terminal into the file, and then I could load that to uh, my laptop. Whatever. Well, while I'm doing that, haven't started the experiment yet. So I decided the itsy bitsy the Cortex M4 does not, though it has an indication that it does, but if it does, no one has provided a library for it. There, I'm looking for a real time clock so that I could set the clock and then have actual timestamps sent to the CSV file. So played with it for about a half a day and realized no, there's no support for this. So I ordered a little real-time clock module. Cheap, cost me like $17 for 5 of them, uh, and it's got a battery backup, and I'll be able to use my little terminal, my command monitor, to set the time, and then never really have to set it again because the battery backup will keep it set. So it'll be nice, but that's going to come later in the week. So I figured while I'm doing it, I'm going to clean up the code even more. And I said, hey, what I'm doing is I'm keeping uh, a FIFO queue of the last 500 samples. Now, one thing that I changed was I'm not going to take a sample every uh, 0.2 seconds because I'm logging to a card. I don't really need to take samples that fast, so I'm sampling it once a second. So what I had in the first version, the first C++ version, was the last 100 samples. And so I have a window of the last 100 samples, and I keep track of the bias across that current window. And the bias is done as a percentage. For the percentage more ones than zeros, or the percentage more zeros than ones as assigned percentage. So um, I was like, well, I've got some time here, and I have some time to do some more statistics on this random number generator, because when you look at it, it you know I stretched the range out so I could see if it's wandering, and it does wander quite a bit in being biased towards ones, biased towards zeros in the last 100 seconds. So I thought I want to analyze this a little bit more. And so I wrote and that was done with a class that called random, uh, I think random bias, or sort of whatever I called it. So I today I wrote a new class, and this is what I'm going to be going with in the future, and that is it it keeps multiple FIFO queues. So it grabs a sample, random sample, and it inserts it into 5 queues. One queue that's the last 15 samples or seconds, in my case, 15 seconds. Another queue that's the last 30 seconds. Another queue that's the last 60 seconds. Another queue that's the last 5 minutes, and another queue that's the last hour. So I'm keeping track of um, 5 windows into the data. Now, yes, I could have had just one queue that was running for an hour, and then compute, uh, and then look at the windows inside of that queue. but I'm just trying to make this easy. I don't care that I'm using more memory than I need to. I've got tons of memory on a Cortex M4, so I have 5 Qs. So what I want to show is some results that I got today. I started it up, and then we went out for basically the day. It turned out I collected samples for 5 hours almost exactly. Oh, by the way, since I don't have a real time clock, I'm reporting the number of seconds since the program started up as a real number. So it's could be fractional seconds. Um, so I took this 5 hour CSV file, and I've got it here or over here, wherever I'm going to put it on the screen. So I've got it on my laptop here. And as you can see, it just looks like a pile of numbers in a graph. But what you're seeing here is in the dark blue is what the 15-second window looks like, or I think I'll just say 15 samples. So over the last 15 samples, it's crazy variation in the bias, but that makes sense because it's only the last 15 samples. So it would be easily biased. Um, and you can see that in some cases, you got these peaks here almost at 100% all of ones. That's what would be the positive peaks here, or almost 100%. Maybe it's 90% of zeros in the last 15 seconds. So it varies wildly in 15 seconds. Oh, also, I'm only looking at the low order bit, and I'll talk about that, but I don't want to distract right now. So I'm going to turn off that thing. Okay, so now what we're seeing in orange is the last 30 samples or 30 seconds. So this window is the bias over the last 30 seconds, and you can see that it's less. The swing is on the bias is much less, um, and it still has some crazy peaks. It's got some peaks, but um, it swings much less. Uh, you can see this little bit of a line in the middle. We'll get to that. That's the 1 hour window on bias window. Okay. Uh, so let's turn that one off. I hit the wrong thing. And now you see in yellow, and now you can really see the last three Qs. Okay. But in yellow, that's the last minute. And you can see why I was saying that it was swinging a lot in 100 seconds. Well, it swings. I didn't have a cue for that, but I close enough. I have a cue for 60 seconds, and you can see that it would go quite a bit into the yellow in these peaks, and it would go quite a bit into the blue green in these peaks, especially when the fact is I'm stretching it out. This graph does not show how the effect of me stretching the range. This is the actual raw bias percentage. So to make it easier to see, I'm going to turn off the 60 seconds. And this looks much nicer now. Now this is starting to look like a not really biased random number generator. So if you look at it over 5 minutes, which is what this little green line is, it has some excursions, but it's really, if you can see where the zero is, it's really hovering around the zero, and it swings a little bit into the green yellow, a little bit into the green blue colors, according to my little display. Um, I'm going to get rid of that. Well, I don't need to get rid of it. You can see it. This this reddish line that is very close to zero is over 1 hour. Okay, and actually you can see an effect in the early time when the queue is not full. It's not. It hasn't been the first hour yet. Um, at the very beginning, the first few seconds, the bias ranges big, and then you can see it settle down over. I don't have a scale on the x-axis. This whole this whole range is up to here is 5 hours. Okay, so uh, it settles down and stays hovering around zero. And this is like practically on the zero, so practically no bias. Then it's a little bit biased red for a while. It's a little bit biased, maybe blue. I haven't really, I need to like magnify this a little bit, stretch the graph scale a little bit. It looks like maybe overall it's slightly biased to ones, but I think for my purposes, this 1 hour window makes the random number generator look like it's a good one that for me to use, and the 5 minute one looks like also good to use. And so I'm going to stop using anything less than 5 minutes. Maybe I'll change some of these windows and look at maybe 1 minute. Well, I already looked at 1 minute, 2 minutes, 3 minutes, 4 minutes. But I don't mind using a 5 minute window and then try to see if consciousness can take this thing, which is fairly stable, if consciousness can swing it. Obviously, since what do I know about consciousness affecting random number generators? We don't really know if this is, well, I think many will think this is hogwash, but consciousness may have a little harder time because in order to swing a 5 minute window, you have to swing it to zeros or swing it to ones quite a bit in order to move it, within the window. Okay, so that's the what I've got so far analyzing the random number generator. Now let's talk about the experiment. I added some code to my little key terminal command prompt, and that lets me start a trial and end a trial. But actually, the trial will end automatically. So, but what I do is I type in start trial, and it will flag in my data stream in this CSV file. It'll it'll flag that I have started a trial. It'll show up on the graph as a blip in the bias, so I can see where trials started. And it will tell me, it'll draw a random number and tell me which color should I go for, red or blue. So it tells me, I don't decide. The only thing I'm deciding here is when to start the trial. I don't have that incorporated in the code yet, where it will start the trial randomly. But I think for first playing around, it'll be fine for me to start the trial. So I start the trial. It tells me what to concentrate on. It flags the CS. It puts a flag in the CSV file, and it continues to collect samples. And then uh, the way I have it right now is it does a 1 minute trial. Now, considering that this is a 5 minute window, 1 minute may or may not be long enough to make it good enough. But I'm just guessing here, right? So I will be able to meditate or whatever and try to influence it over a minute. And all that will be logged. So the whatever happens will be logged to the log. And, once I have the real time clock, it'll have the date and time stamp in the CSV file. So um, that's my update. Oh yeah, that other thing that I was going to mention in CircuitPython, it was nice that you could just import OS module and use os.urandom to get a random byte. It's done for you nicely in Python. It's not. I could not find an equivalent interface in Arduino land, in C++ to get access to the 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 TRNG on the chip. So fortunately, and this is why I'm so, happy that people post things onto the internet. Fortunately, I found one person who was using C++. He wasn't using it for an Arduino, or maybe it was C. He wasn't doing it in our Arduino land, but the symbols he used, are pretty standard. Um, and so the defines and the data structure for the TRNG is defined in the it's called the variant, I guess, the Arduino itsy bitsy variant. Okay, so the data structure for the TRNG is defined, and they happen to use for inside of the structure the same symbol names for the members of the structure as this other guy's whatever SDK he was using. So I was able to grab, it's like 4 or 5 lines of code, and be able to initialize and turn on the hardware random number generator, and then you can draw samples. Now, his code was drawing 32 bits at a time. Now, I don't know if I could draw less. It's not important. So, I mean, I was just happy to be able to get random numbers, out of the TRNG. So I draw, wow, 32 bits, and I'm only using the low order bit. Um, it should be, if it's truly random, if it really is a truly random number generator, okay, uh, then any individual bit should have about an even probability of being a one or a zero. Okay, so I should be able to take any of the bits in the random number, the 32-bit random number, and use it for a one or a zero. So that's it for today. The next update might be when I get the real time clock in, and right now I've got the itsy bitsy, I've got the SD card module, and a bunch of jumper wires between it attached to a USB cable. It kind of just hangs. Okay. Now that I'm going to add a third module to the setup, I'm going to put it on a breadboard. So I'm going to put it on a plug board, so it's a little bit neater. Um, and next step after that might be to use a perf board and wire them up into sockets. Uh, but that might not be necessary. I think it'll be fine running it off a breadboard. I'm not trying to mass produce these circuits. So, okay, I think this video has gotten quite lengthy. So, goodbye for now.